Good afternoon, everybody. My name is Christiana. I'm the event manager for Chemspec Europe, and it's my pleasure to introduce the next webinar in our digital presentation series. This will be Sabin Metal Corporation's webinar on precious metals risks and rewards. And before introducing our presenter today, we would like to remind you that the session is being recorded, so that if you are, that we do invite attendees, apologies, we do invite attendees to write questions into the chat box at the side on your dashboard, and at the end of the presentation we will have time for question and answers with Brad. And however, if we do not get through to all the questions, rest assured that somebody from the Sabin Metal team will be in touch to get in contact with you and answer any questions you may have. Now, without further ado, let me introduce Brad Cook, Vice President of Sales and Marketing at Sabin Metal Corporation. Now, I will hand over to you, Brad. There we go.
Thank you.
Okay.
And let's see if modern technology is being friendly today. Then all of you are viewing my screen at this point. And good morning. I'm Bradford Cook, as I was kindly introduced. I've been with Sabin for about 10 years now, but I've been in the precious metals industry for embarrassingly almost 40 years at this point. And I'd like to start out by thanking all of the people that have helped us put this together and allowed us to be here today, and thank all of you for joining us. I'd like to, as introduced, I'd like to talk about a bit of the risks and rewards within the precious metals industry. As you can imagine, like most things on Earth this last few years, the precious metals industry has been up and down and sideways and flipped over and turned inside out a few times between the pandemic, the Russian and Ukraine conflict, and on and on. We'll touch on a few of these things, but I wanted to start out by informing you that this entire presentation has been constructed from 100% recycled pixels. So we're doing our part to stay even more green than some of the other webinars. How's that for a start? Ask yourself a few of these questions. Make a mental note of your answers. Have you ever been, ever used contact lenses, for example? Are you watching me today through contact lenses, or perhaps you've had LASIK surgery? Maybe you've used a razor for some reason this week. Do you know anyone who wears pantyhose? Do you ever travel by plane or by car or by boat? Do you ever find yourself in need of vitamin 40 or ibuprofen, as it's known? I call it vitamin 40 because after you turn 40, I think you have to take it every day. Is your home insulated with fiberglass? Do you ever use a cell phone or a laptop or a computer? I think many of you probably know where I'm going with this. If you answered yes to any of these questions, then you have platinum group metals to thank, and obviously some creative minds in human history. These elements within the platinum group are absolutely on the cutting edge of so many technologies that are crucial to mankind. Not just convenient as some of the things I've listed, but absolutely crucial. And I'm talking about world health, the environment and conservation, and of course, energy production and energy storage. So everything from a fuel cell to a chemotherapy drug. These platinum group metals are absolutely astounding once you get into taking a look at them. So we're going to talk about those metals a little bit more and what's going on in the world with supply and demand. And then I'd like to finish by running quickly through the value chain drivers of precious metal catalysts throughout their life cycle. The grand total of all platinum group metals that have ever been mined in human history, that are above ground, that is estimated to be about 20,000 metric tons. Now, 20,000 metric tons is nothing to sneeze at in terms of volume, but to put it into perspective, the world production of iron is 100 million metric tons per month. So 20,000 metric tons of metal is really not that much, especially when you consider the absolute density of some of these platinum group metals. For example, if you gathered all the platinum together somehow on planet Earth, it would fit inside a 4-bedroom house. And that probably sounds impossible for some of your engineer minds out there, but consider the fact that a cubic meter of platinum is absolutely an astounding amount of weight. Even just a 20-liter bucket would weigh something in the neighborhood of 1,300 pounds. So what's that, 600 or so kilos? It's incredibly dense metal. They're probably some of the most recycled things on planet Earth, because it's always worth someone's time and effort to get that precious metal back from whatever byproduct or waste stream that it's been caught in. And I did a calculation last year that if Sabin Metal were a mine, we would be the 6th largest mine in the world in terms of the number of ounces of pure platinum, palladium, and other metals that we, the 6th largest platinum mine in the world, in terms of the production that we put out. And recycling is becoming more and more important in so many ways, but for precious metals, as you'll see when we go through some of these topics, it's becoming even more critical for the precious metal market. They estimate that 20%, over 20% of all consumer products now either contain platinum group metals or are made using platinum group metals. So before we take a look at how we're all using these platinum group metals around the world, we have a quick poll question that I think my colleagues are going to post up there.
No problem at all. I will just run the poll now. You should all be able to see this now. Okay. All right. Just a couple more seconds for those that may not have voted yet. Okay, wonderful. Thank you very much. I'll close the poll now.
Thank you. That's we're just at about 63% of the audience are using precious metals. Interesting.
Yeah.
Let's take a look at the platinum demand by application. So what you're looking at here is the last 100 years of platinum use on planet Earth. So in the 1970s, you see this huge spike and this beginning, if you will, of something called AutoCAD, automotive catalysts, or what rides around in the catalytic converters in cars for pollution control, began in the 1970s, was introduced in the 1970s. And around 1980, they switched from platinum to palladium use. But around 2001, I believe, they switched back to platinum. So you'll find a majority of platinum content in the combustion engine, regular passenger vehicles, and you'll find a majority of palladium actually in the diesel vehicles. But there will almost always, you'll find platinum, palladium, and rhodium, another platinum group metal, in the automotive catalytic converter. So in a nutshell, as we look at 2020 figures, about 1/3 of the platinum in circulation today is used in catalytic converters in cars. About 1/3 is industrial use. That's all of us that answered that poll positively. All of your gasoline production in the petroleum industry. Interestingly, there's fiberglass production that requires a great deal of platinum and rhodium. And then about 1/3 is jewelry and investment. Let's take a look at this. This next slide is the palladium demand. This has become very, very interesting. 100 years of palladium. So about 90% of the palladium that is above ground on planet Earth is riding around in these catalytic converters. So since the 1970s, if you'll pardon the pun, the main driver of the palladium market has been automotive sales. So when we look at the recent expansion into the developing world, the emerging world, the growth of the automobile market there, according to Scotiabank, we were off quite a bit in 2020 due to the pandemic and the chip shortage. It was about 85%, about 15%, I should say, low in terms of automotive sales. So that was hitting the palladium market hard. No new cars means no new catalytic converters, and no need for the palladium. In 2021, they're describing a slight recovery to about 67 million vehicles sold, but that's still 8 million cars short of the number of vehicles sold in 2019. In terms of the supply, when we look at the platinum and palladium supply from mining, one should always keep in mind that about 70% of the platinum and almost 40% of the palladium that is mined and produced by these mines every year is from South Africa. These South African mines obviously get older and deeper every year, and these are obviously the major deposits on planet Earth. There's not going to be another South Africa found somewhere on planet Earth, and the challenges continue in that area. As you've all read in the news, I'm sure, the labor issues, water supply, electricity, and other infrastructure issues. But also remember that the deeper these mines get, the more expensive it is to get that ounce out of the ground. It takes about 10 metric tons of rock to produce 1/10 of an ounce of platinum in most cases. There are some richer veins, but it's usually between 5 and 10 metric tons of rock to get that 1/4 ounce that they're looking for in processing. So it's a lot of movement. That ore quality deteriorates as they get deeper and deeper into the mines, and so there's a stressor there. About 15% of the platinum production and about 50% of the palladium comes from Russia. The London platinum and palladium market, which is the industry standard for the provision of pure platinum and palladium to the world, the LPPM as we call it. Essentially, and I'll even read you from their own description of themselves, they produce what is called a good delivery list. This good delivery list are the acceptable refiners of platinum and palladium plates and ingots to the London market. It's developed by the LPPM to facilitate international distribution and the acceptability on technical grounds of standard plate and ingot platinum and palladium produced by refiners who meet the criteria for inclusion in the list. Now, that criteria, and I can speak to this because Sabin are good delivery members. There are 28 good delivery companies in the world. This designation is granted when the LPPM has successfully audited the sourcing of the precious metals from that refinery that desires to be on the list, and also conducts a full audit of their ability to produce, melt, and analyze the precious metals and ensure that it is that 99.9+% quality of platinum and palladium to the market. The reason that I'm throwing all this out today is just a couple of weeks ago, the LPPM announced that 2 of the mines in Russia that were previously on the good delivery list have been suspended. Now, as I said, 50% of the palladium in the world comes from these mines in Russia. This is going to cause a severe tightening of the market. Far be it from me to say, exactly what's going to happen to the price and the availability of the metal and the lease rates for those metals from the Mitsubishis of the world. If I knew that ahead of time, I would be sitting on a Caribbean island with a drink with a little umbrella in it instead of standing here talking to you today. However, it bears mention that these recent events, and as we said, when we throw into the mix that there are allegations against Russia of various severe activities and atrocities, and these types of things in the news are probably going to result in even tougher sanctions. And so there's quite a bit of concern in the precious metals industry surrounding these events, needless to say. Moving on to demand, this is the overall demand for precious metal, for the platinum and palladium. This is probably, I just want to switch up a little bit because I didn't mention this previously when discussing these matters, but there's a company called Johnson Matthey. Many of you may have heard of if you're dealing with precious metals. Johnson Matthey has served as the World Bank for precious metals, essentially, in the UK. They allow electronic transfers of platinum palladium, for example. If you need a ton of platinum in the United States, and you can buy it in Switzerland and electronically have it transferred through Johnson Matthey UK to the Johnson Matthey US side, and that physical metal would be made available to you in the United States for pickup rather than shipping across the pond, as they say. But with Brexit, it's thrown another curveball at everyone. Trying to transfer these metals has become a triple challenge. You've got the labor shortages, you've got the transportation and logistics crisis, and you've got Brexit. So I hate to call it a perfect storm because it's almost gone beyond that, where every month there's something else stacking up affecting the precious metals market. The ups and downs that we've seen lately, palladium lost, I think, about 10% yesterday per ounce. These things seem to be fairly well balanced right now. The pressures upward and the pressures downward seem to be equalizing a bit. But I highly recommend that your company takes a forward look, especially with regard to this next slide. The recycled number of ounces is getting better. We deserve a pat on the back, so to speak, for what we've done in the recycling side. But let's remember that so much of these metals now are in the hands of consumers rather than just in the hands of industry. In terms of industrial use, these platinum and palladium ounces historically would be in a carbon catalyst or in an alumina catalyst, which is fairly simple to refine. It's only 5 or 6 different elements in that matrix. But now we have an enormous amount of platinum and palladium that's in cell phones and computers and laptops and televisions, and all of these devices end up in landfills, or if they are recycled, a cell phone, according to Encyclopedia Britannica, has about 44 different elements in it. So it's much more complicated for the recycling side. But if you look at this growth, the number of ounces of platinum and palladium that's being returned to the market, obviously the vast majority of that 3 million or so ounces of palladium that's being recycled every year is because the automotive catalyst boys have gotten very, very good at capturing those used catalytic converters and getting the recycled ounces back into the market. But when we overlay the demand, supply, and recycling, here's the picture that we have right now. Platinum is in fairly decent shape. We've got about 200,000 ounces or so of surplus, and that's expected to continue for the foreseeable future, let's say. The palladium, on the other hand, is about 1 million ounces in deficit. So these numbers were just a 2021 forecast about halfway through the year of what might happen in 2021. So clearly, these numbers do not include any of the recent events that we've been talking about. So as far as expectation goes, the lease rates and the volatility, I think the risk of volatility is going to remain high, and the restrictions that we're looking at in terms of the mines out of Russia and other forces acting on the market, the availability is certainly going to be strained going forward. So the sheer amount of precious metals that are needed, the platinum metals that are needed every year, are without question making mining critical. And there's a lot of extremely smart people working on how to protect workers, at the same time managing that deteriorating ore quality and the other infrastructure challenges, shrinking their carbon footprint, etc. But I think it's clear that a recycled ounce of precious metal is always going to, if we can reuse that ounce, then that's always going to result in some degree of lower emission and mitigate that energy use of mining an ounce. So I'm certainly not saying we can do away with mining. Absolutely not. This is critical, but we need to continue to get better at reusing every one of those ounces as many times as possible and maximizing the recovery in order to enhance that refining, recycling cycle that goes through the market and people like Sabin. So moving on to the value chain, I put this slide up to just take a quick look at what we would call the general value chain driver definitions. This is sort of the common knowledge version of value chain drivers. Your inbound logistics, your operations, your outbound logistics, your sales and marketing, and then of course your services. When we look at the precious metals catalyst value chain drivers, I have changed them just slightly. Let's look at the inbound controls, as I call them. You've got to purchase that catalyst. So the fresh catalyst that's coming into your company, you need to know what the value is, and yet that you're getting the precious metals that you're paying for. Most companies do this by having some sort of volume or weight check upon delivery, or possibly even at the manufacturer's site ahead of time. And then to go along with that quantity, you need to know the quality. So there can be an analytical step. The manufacturer is certainly going to provide you with a weight and an assay certificate for what you're buying. Many customers add an extra level of security, protection, and control by having a representative of their company witness the weighing and sampling of that fresh catalyst before it comes in. Then, of course, there's the loading of the catalyst. It's simple enough to say anytime the catalyst is touched and handled is an opportunity for loss. So you need to make sure that all of the catalyst that has been designed or designated, I should say, to be loaded into that reactor for use, that it all gets in there, that everything is cleaned up. Some of these catalysts are 0.5% palladium up to even 10% platinum or palladium. So it doesn't take much spillage on the ground, a little bit of dust, and you throw in that weight that platinum carries around, the platinum group metal density. It doesn't take much before there's thousands of dollars in a dust collector or being walked into the floor around a machine. So it's housekeeping, in other words. And then, of course, accounting and keeping track of having a program within your company so that you know how much precious metals you have and where they are. Operationally, I think it's pretty straightforward. Wherever that catalyst is, there may be a sludge tank, there may be filters, there may be dusts that are collected in some other way. During that entire runtime, having control of your operation and knowing where those catalysts are under control and the integrity of that catalyst lot is being maintained. The outbound controls, identical to the loading, is the unloading. You got to control the dust. You got to make sure that you're picking up every bit of that catalyst from the inside of that machine where it was used, or that stream, and then accounting for all of it and keeping track. In terms of contract management, I don't think we have time to go through everything I've noted here, but I just want to touch on a couple of topics. The reason I put contract management into this is because it's such a niche business in precious metals refining that many of the terms and conditions that you'll find in a refining contract for your precious metals, you're not going to see these types of clauses and paragraphs in a standard contract. You may not see it in any other kind of contract. For example, splitting limits. Splitting limits are if the customer has an assay done of the final sample of the material, and of course, Sabin or your precious metal refiner is going to have their assay, they'll have a sample as well, then those two assays are compared to one another. The splitting limit is how much money have you contractually agreed to split should the assays be a bit apart. Standard procedure for Sabin and most of the industry out there is 1% relative. This 1% relative splitting limit means that as long as we're within 1% of one another, then we'll average the two assays and we'll agree to settle on the mean of the two. But I've heard competitors out there around the world who sometimes have a 5% splitting limit or even a 10% splitting limit. And this is just irresponsible. This is the equivalent of saying that as long as we're within 10% of one another, we'll split the difference. And that's incorrect. And I dare say this because if two labs can't get within 10% of one another, then something's wrong. Something's either wrong with the samples that have been provided to those labs, or something incorrect has been done at one of those labs, and one of those labs is therefore got a bad assay. So the splitting limit remaining at 1% relative is actually quality control. You're making sure that you've got a good sample because it can be duplicated in two separate laboratories. And then the performance in those laboratories is up to snuff because they're coming within that nice close agreement. And then just one other, it'd be lot sizing. Lot sizing is a misunderstood term out there. It certainly doesn't mean anything about volumes and the ability for a precious metal refiner to produce or utilize a maximum amount. It's actually about limiting the amount of money that is riding on any one asset. So it's never in anyone's best interest to have too much money on any single lab analysis, because standard deviation and repeatability of an analytical result is going to stay constant. A lab doesn't get better at platinum analytical performance just because more money is involved. So instead, if you reduce the amount of money for that lot, in other words, someone sends you a $4 million package, well, break it down into 8 $500,000 lots, and have 8 separate assays for each of those smaller value lots, sublots, if you will, rather than have one assay on $4 million worth of precious metals, because then your 1% splitting limit is a tremendous amount of money. No one wants to split. Would it be $40,000? That would be insane. So, and then lastly, the value chain drivers would be services. And I guess by rights, this should be first. Number one out there is you have to be dealing with an honest precious metals refiner, or none of these other things are going to matter. And so check out the people that you're going to do business with. You check them out in every way that your due diligence process allows. Financially, the news, investigations of their environmental records, safety, audit them yourselves. If you can't, then make sure you're hiring an expert firm out there, what we call the umpire firms. They're very, very good. The SGS and Bureau Veritas and several others, Alfred Knight, Alex Stewart, around the world. These guys are long-time laboratory and boots on the ground services to make sure that you're being protected. So you need to ensure, number one, that the precious metal refiner you're going to deal with has got a clean record, and number two, that they can actually do what they say they're going to do in terms of proper sampling and correct analysis. So having that second pair of eyes, if you will, on site, your third-party witness to watch the material process, is another great service I recommend. At Sabin, we encourage it. It's actually human error prevention, if you will, to have that representative making sure that every scale is zeroed and calibrated before it's used, and that the sampling process worked, and controlling the custody of those samples at the end. So it's what I call catalyst life cycle management. The key factors are, as we said, anytime it's handled is an opportunity for loss, verifying and witnessing at all steps. The carbon negative is a presentation that is on the Sabin website, which I'll provide. And it's about the processing of carbon catalysts. Mainly it's in the petrochemical and petroleum industry, but it's an interesting read if you get a chance about the way that we handle carbon and the effect on the industry. And everyone's talking about carbon and their carbon footprint these days. And then understanding the weights, what I call apples to apples, making sure that everyone has an opportunity for a sample to be run by their own independent lab for comparison purposes with each other for the final settlement, and not you must have a weight and an assay when you go through this precious metal recycling process, not someone making you an offer in a blind sense and you either take or refuse the offer. Those days are gone. The precious metals industry, as I say, I've been around for almost 40 years now. if I'm asked what's the biggest change I've seen in the precious metals industry in 40 years, it's without a doubt, it's compliance. It's compliance environmentally, it's compliance in terms of the scrutiny that every ounce that comes into a precious metal refinery has got to be documented, that it didn't come from a cartel or a terrorist organization or a sanctioned individual or country or company. So that's part of knowing who you're dealing with. And all these things are within what we call our knowledge center on the Sabin Metal website. I won't go into depth, but there are links you can use that we can provide for you. And I think we're ready to move on to a question session. I put together a quick graph of, in blue, you'll see the chances that Brad will have all the answers is 0. And yellow represents also 0, but it's just in yellow. So we can, if there's any questions, I'm happy to take them. I think we do have a few questions here that have popped up.
Yeah, hi Brad. Thank you for that start of that. That's great. Yes, we have. We've got a couple of questions. One was asking if you could explain a little bit more about the methodology of sampling and analysis.
Absolutely. There's actually 2 phases. You could call it the front end and the back end of a precious metal refinery like Sabin. We're what you call a primary refiner. A primary refiner means at the end of the day, Sabin is making pure metal. We're making platinum and palladium, as I say, to go back with that LPPM certification into the market, to the exchanges of the world, the banks of the world, the jewelry companies and the catalyst manufacturers know they're going to get high quality. There are also secondary refiners out there. These are people who can take in precious metal materials. They may upgrade them a bit and combine them, smaller parcels, into larger lots, and then they end up shipping them to people like Sabin and Johnson Matthey and the others around the world for the final precious metal refining and production. But all of those people, primary and secondary, the front end is when they take a sample of the material that is going to be the basis for the evaluation of that asset value for the customer. So if Sabin is taking in pharmaceutical catalysts and fine chemical catalysts and petroleum catalysts from many different clients around the world, each one of those customer shipments that comes in has to be treated, processed, and homogenized independently unto itself so that it can be sampled and analyzed, and then the weight of that customer lot times the assay equals the content of precious metal value, and that's the basis for either the transfer of metal on the client's behalf to the account they designate, or Sabin simply cutting them a check for the value of the precious metal. So many people think erroneously that when they send their material into Sabin and the rest of us, we're actually extracting the precious metal from their material and then telling them how much there is. And that's not correct. There's actually a processing and homogenization phase so that it can be sampled properly. And then that sample is taken to the laboratories, hopefully on behalf of the client and on behalf of Sabin for comparison purposes. And an analytical result is agreed upon so the money can change hands. Then the back end, as I referred to, is when you've settled with your customers. Everybody's been paid for the precious metal value in each customer shipment, and then Sabin can combine like materials into large production batches to go through the actual refining stages and get to that pure platinum or palladium or gold or what have you.
Right. Well, that's hope that answers the question to the attendee. What's the meaning of the term payable metals with a precious metal refining contract within that concept? Sorry.
That's a good question. Thank you for that. Payable metals is a contractual term that refers to either the ability and willingness of the receiver, the precious metal refinery, to pay you for those metals. So if someone, for example, if someone shipped a platinum catalyst to Sabin and it had a level of copper in it, they may want Sabin to compensate them for the copper value. Well, Sabin's contract might say, you know, copper is not a payable metal from Sabin because we don't refine copper. We don't process the copper. It ends up in, you know, in a waste stream or something. So this is important to know before you deal with a precious metal refiner for two reasons. One, you know, you want to make sure that the level of precious metal in your material is significant enough that contractually that is a payable metal. If you've got 0.001 palladium, it doesn't matter how many tons you have, and if you think you have 3 ounces of palladium, you know, and it's in 40 tons, it's just not rich enough. There isn't enough content of palladium for anyone to commercially extract it and end up, you know, making money getting it out. So it's the old adage about seawater. You know, they say there's gold in seawater, and there is. There's an amazing amount of gold in the oceans, but the content percentage is so low that it would cost you more money to get the ounce of gold out of that volume of water than the gold is actually worth. So this sort of contractual term ends up out there, payable metal. One other slightly important aspect of this, especially when you're talking about petroleum and petrochemical, not so much the fine chemical side, is acid solubility. And the reason I bring this up is because most of the companies in the world refine precious metals by dissolving the catalyst in acid or caustic. They'll drop the entire batch of precious metal catalyst into aqua regia tank, for example, and dissolve all of that material into solution. And then once it's in solution, the precious metal can be extracted in a singular sense, so that you're creating a platinum or palladium sponge, a fine 99.9% purity precious metal. Sabin, on the other hand, for the petroleum alumina catalysts and the zeolites, the silica alumina, we melt all these catalysts. We're pyrometallurgical recovery of precious metals. So we're melting these catalysts down and creating ingots with collector metals and drawing off the alumina, etc. But this preliminary refining stage of melting means that all of our contractual settlements for payable metals are based on the total content of precious metal, where some of the hydrometallurgical companies, again, that these tricky contract terms, the payable metal may be based on the acid soluble platinum or the acid soluble rhenium only. And that's important for the customer to know, that the dissolver company who's refining precious metals hydrometallurgically, they're only going to pay for what they can get. If they're dissolving, then if it's not acid soluble, they're not going to recover that precious metal, and therefore they're protecting themselves in the contract by stating it that way. So
okay, thanks, Brad. And we've got another question here. Is there progress in the recycling of metals in phones or computers, laptops, and so on?
Yeah, there really
mining?
is.
I think the question was, isn't it like mining as well, in a way?
It is. That's very clever, because you know you may have seen in the press, they call it above ground mining. I think that it started out much like, I'm not sure in Europe if this had a different name, but in the United States it was called Cash for Gold, and you'd see these little kiosks pop up in public malls and so forth, and online presence, individual owner operators would have parties, home parties, where people would bring their old jewelry and get rid of it. So it was essentially, this mobile pawn shop with a different name on it. The pawn shops, the cash for gold guys, they're going to give you a fraction of what the gold ounces are worth in your jewelry. Now that may be fine for the individual with a necklace or two. But on the full recycling side, it's changed from, can we make some money by grabbing jewelry from people and only paying them 10 cents on the dollar for the gold value? It's changed now to entire communities, countywide programs, even statewide programs here in the United States. I dare say Europe is always a couple of steps ahead of the United States when it comes to things like recycling and reuse and recover operations and organizing them. So these ideas have changed into more of a focused community effort to make sure that these electronic materials don't end up in landfills and or being wasted in some way. So yes, it is progressing. It's also helpful to cut the number of middlemen out of the process. So you see large companies who recycle electronics that are across, especially in Germany. There's a number of them, and in Sweden. They've done an enormous amount of work in separation technologies. If you crush a phone and try to melt it, you're going to have a lot of problems. But if you can crush a phone into pieces and then through different technologies separate those pieces and have the plastic go into one stream and the red metal go into a separate stream and the magnetic portions go into a separate stream, then now you're creating something that's not just more easily recycled, but you're creating a large volume of desirable material streams for the people who do it. So it's a I would say yes, it is happening. Is it happening fast enough? Hard to say.
Well, thank you very much for that question. And I think we've got one. I think you've touched on that a little bit in your presentation already. You mentioned lot sizing can be used for quality control purposes. Please, can you explain how this would work?
Yeah, of course. The example that I gave was a $4 million shipment that came in, and from Sabin's standpoint, we would separate that into $500,000 parcels. So there'd be 8 sublots that would be, each one would be homogenized separately, sampled separately, and weighed separately, and then you'd have 8 individual assays that went to the laboratory. That 1% splitting limit, as we call it in the contracts, is there to protect you then. You've got each individual $5,000 1% splitting limit. And that's terrific. That means that the most you're going to be asked to compromise, whether it's whoever's higher or lower on the assay, is to move $2,500 in one direction or the other when you split the difference with the other laboratory. The splitting limits that have been designed by some of my competitors of 5 and 10% are going to put you at an even greater risk. So I have seen examples of people taking that $4 million or even $8 million lot and having a single assay done on the lot. And so you've got $8 million riding on one assay. So already, the standard deviation and repeatability in the laboratory, I guess it's worth mentioning that there's another sort of myth out there in precious metals that you just take a sample and you put it into this black box and you press a button and a number comes out and it tells you, the precious metal value. It couldn't be further from the truth. There's multiple techniques and multiple separate trials that are done on every sample that comes through the Sabin laboratory. And I know my competitors and vendors and partners out there around the precious metals industry, it's the same. So you need to be able to duplicate your own results in your laboratory very carefully by method comparison and by multiple runs. Then you know that you can average those results and report, an exchange of assays with the two parties for settlement purposes. So it's very delicate matter, and reducing that lot size just makes the laboratory portion can be very, very precise, but the lot sizing is just a simple way to make sure that you're minimizing the risk for both parties.
Yeah, that makes sense. Thank you very much. I think that brings us to the end of our questions. If there is anybody else in the audience that would like to ask Brad a question, please do so. We still have a couple of minutes time. Yeah, and in the meantime, no, Brad.
I'm going to throw up this last slide with my email address. If anyone does have a question they'd like to follow up with me, I welcome communicating with anyone, and thank you very much for being here with us today.
Well, we at Chemspec would also like to thank you for attending, and we can also ask you, if you haven't already registered, do come and see Brad on his stand at J54 at Chemspec Europe in only 5 weeks' time. So the show opens exactly today in 5 weeks' time on the 31st of May, and the Sabin Metal team will be there.
Looking forward to it.
Lovely. In that case, if you do have any more questions, please feel free to send those questions through to Brad or indeed to us, and we will be happy to forward them on. In the meantime, thank you all for watching. Thank you very much, Brad, for presenting.
Thank you.
It's a pleasure to have you on board, and we will see you in 5 weeks' time.
See you there. Thanks a lot.
Bye-bye.